Welcome back, everybody. Mr. Renniker here again. And for part two of this lesson, we're now going to be focusing on cube roots instead of the square roots we focused on in the last part. And similar to our last lesson, our main objectives here are going to be to calculate cube roots and learning how to do that. And of course, we'll evaluate some different expressions that involve cube roots. We'll go ahead and get started. So we'll start off defining what a cube root is. A cube root of a number is a different number that, when multiplied by itself and multiplied by itself again, equals the given number. We also refer to something called a perfect cube, which is a number that can be written as the cube of an integer. We use this symbol here. It looks similar to the square root symbol, although it does have this extra digit of 3 up here to represent a cube root. Let's break this down briefly before we continue. It says a cube root of a number is a number, and we're going to stop right there. A cube root. We now know that cube root can be represented using this symbol, so we're going to say cube root of some number, and I'm going to call that number A. So that cube root of a number is, and in mathematics is typically, represents an equal sign, is a number, so that's going to be a different number, we'll call that number B, that, when multiplied by itself and itself again, equals the given number. So basically it means that if I were to take this number B and multiply it by itself, and then by itself again, that would equal the given number that we had started with. So these are the inverse sections of this cube root idea. So we'll see how this works out in our examples. So we will start simply by finding cube roots of numbers. So in part A, they are asking us to find the cube root of 8. In other words, what number, when multiplied by itself and by itself again, will equal the given number we started with, 8. These take just a little bit more focus than square roots. I'm going to caution everybody to be very careful with these and really make sure you're checking through your multiplication. It's also very easy to kind of resort to accidentally using addition instead of multiplication to find your cube roots. So just one more thing to be cautious of. But we're looking for numbers that, again, would multiply together to become 8. In this case here, the cube root of 8, of course, would be 2. And that's because 2 times itself again is 8. 2 times 2 is 4. 4 times 2 is 8. And that's how cube roots work. Now, in the previous section, again, about square roots, we didn't see any negatives under the radical sign as we do here, but it should work out a little bit more cleanly because of the fact that we have cube roots, specifically because a cube root, meaning we're using an exponent or the inverse of, which is 3, an odd number, that changes the result of multiplying all the negatives together. We'll see how that works. So what is the cube root of negative 27? So again, what number times itself is going to equal a negative 27. So how do we end up with a negative when multiplying three numbers together? Well, if these were all positive values, of course we'd end up with a positive because one positive times another is a positive, times another is a positive. That's not going to work out. But if they're all negative, will that help at all? And we'll just have to test that out to see. If we had a negative times a negative times a negative, well, what happens here? Well, we end up with a negative times a negative. That's a positive, of course. Then we have a positive times the final negative, and that thankfully does result in a negative solution. So make sure that your values here are going to be negative if the value under the radical sign is negative also. So finally, what negative number can we multiply by itself and by itself again to get 27? Now you might want to resort to something close to 5. It feels natural because of what we've done with square roots in the past, but you'll see that this gets extremely large very quickly for the simple reason that, well, 5 times 5 is 25, times 5 again, well, that's well over 100. That's way too big. We're only trying to get to 27. But thankfully, that just means that we now know that 5 itself was too large of a cube root, so we need to pick something smaller than 5. I'm going to try negative 3 and see what happens. And we start off first. We already know that the solution here would be a negative. So we can just do 3 times 3, which is 9. and 9 times 3, there it is, which is actually 27. So the cube root of negative 27 is negative 3. Now, I'm using this extra process that I just erased of checking to see if it gives me that given number under the radical sign, but the cube root is actually just that one value, that one number that would get multiplied by itself and itself again. All right, finally here we have part C, and we're going to look for the cube root of 1/64. I would encourage you guys with the fractions to ask yourself what fraction times itself, so a number over a number. That'll help you just kind of process the numerator and denominator separately, which makes a lot of sense. So when we say, okay, what number can be multiplied by itself and by itself to equal 1, and that one's very obviously just going to be 1. But then for the denominator, what number times itself is going to be 64. Well, let's go back to part B. We had first tried to use a 5 there, and we figured out that 5 times 5 times 5, that's over 100. I'm only trying to get to 64. That's too big. And we used 3, and that got us to 27, so that's not enough. So it would make sense that maybe we should try something in between, like 4. What's 4 times 4 times 4? 4 times 4, that's 16. 16 times 4 again, that's thankfully 64. So that C, or that denominator, should be 4. The cube root of 1/64 is 1/4. Before we continue, it's going to be very important to mention, so please make sure you listen carefully to this next statement or so, that square roots and cube roots are, at this point in your math career, tantamount to multiplication facts, things that over time and with practice you can and quite frankly should have memorized. So please make sure that you guys go back to our Google Classroom. I will have some cube and square root notes or documents available that will list some of the most common cubes and squares and cube roots and square roots for your reference so that you can add them into your notes or print them or whatever's available to you. So that'll be a resource I have ready for you. Again, similar to what we did with squares and square roots, we see here that cubing a number and finding its cube root, those are inverse operations. That can be helpful when you're solving a variety of equations, when you're evaluating expressions and simplifying them, and so on. We can use this relationship to evaluate expressions, like we said, and solve these equations. So we're going to take a look at some of those examples next. So in our first example here, where we're evaluating expressions, involving cube roots, we have this scenario where it says 2 times the cube root of negative 216 minus 3. And as I read that, it might be valuable for you guys to rewrite this just for clarity as you go to solve them. We have 2 times the cube root of negative 216 minus 3. And the reason that I might consider expanding this out to see that multiplication is because ultimately, folks, what we're simply doing is simplifying a number sentence, which means it's going to be very important for us to follow the order of operations. Of course, there's a variety of ways that we remember the order of operations, like PEMDAS, or please excuse my dear Aunt Sally, and we've also grown to realize there's truly only 4 levels to that order, but one way or the other, remembering that order of operations will come in handy is going to help you be successful here. Oh, excuse me. Okay, so when we go to evaluate the expression, we need to start through the order, which is begins with parentheses, which we don't see any of, so we move on. The next step we would typically call exponents, but truly that next step actually refers to powers, which we see as exponents, but also roots, which, believe it or not, is another type of exponent in one way. Since that next step refers to powers or roots, we obviously have one of those here. So we need to evaluate that, and I'm going to go ahead and rewrite everything else before we finish that up. So our first step is going to be able to find the cube root of negative 216. Well, since it's a negative, I know that the cube root will also be a negative, and now I have to simply consider what is the cube root of 216. As I mentioned a few moments ago, you will have this reference sheet available for you on Google Classroom. You can also use a calculator to find cube roots if you know the proper keys to use. Otherwise, you might have to use Google or another resource for yourself. The cube root of negative 216, though, is negative 6. Okay, so we got rid of our powers and roots, or at least we simplified them. Next, would be any multiplication or division. And of course we have that here. 2 times negative 6 is negative 12. And we still have a minus 3. And we only have one operation left, so we take negative 12 minus 3 more and should end up with negative 15. And we have evaluated the whole expression. So again, when evaluating expressions, keep the order of operations in mind, and make sure that you refer to a reference sheet. Do spend some time memorizing cubes and squares and square roots and cube roots. And finally, I'll give you a couple examples to try on your own if you want to test your understanding before getting to the assignment. Okay, I have 6 problems here for you to try on your own so that you can see if you've understood what we've gone through in this lesson or if you need to ask more questions before we continue. Folks, if you would like to do these on your own, please go ahead and pause the video here in just a few moments, and shortly after the answers will appear for you to see how you've done. And here we go for solutions. Number 1 is 1. Number 2 should have been negative 7. Number 3 was negative 3/10. 4 was positive 10. 5 was negative 21. And 6 was positive 21. If you got any incorrect as you tried on your own, I would encourage you guys first to go back through now that you know the correct solutions and try again to see if you can find your own mistake. If you're having a lot of difficulty, of course, reach out to me via email or Google Classroom to see if I can offer you any help. Or, of course, meet me in our live Zoom tutorials every Thursday, and I'll be happy to give you some extra advice then. Otherwise, you guys should be all set to go for this lesson all about cube roots. We have learned how to calculate cube roots. We've also learned to evaluate expressions that involve cube roots, and I will see you guys next time.